Welcome to 4.5. In 4.5, we'll be doing modeling with trig functions. So what we learned, kind of like the graph that we learned, the function that we learned, the general behavior is like this, where you have something that's oscillating. Oscillating is just moving between 2 points at a constant rate. So something is moving up and down and up and down and up and down. And the most basic problem that we did start with in class, which we will use for this class, we'll just do 2 problems in this video. So the first one is we just have a Ferris wheel. Let's start with the basic Ferris wheel. And in this Ferris wheel, suppose that we have this information. Reading through it, we board a Ferris wheel at a 3 o'clock position. This wheel, radius 3, it rotates counterclockwise at a speed of pi divided by 4 radians per minute. We want to graph the height above the ground as a function of time. This is a bit more advanced than the first one that we did in class, but I think it's fine. So let's always draw a diagram, as much detail as you want, but there's a couple key things that I'll outline that I do want us to have for this process. So first off, it says we board the Ferris wheel at a 3 o'clock position. 3 o'clock is right here, because normal clock, 12, 3, 6, 9. 3 o'clock is right there. So I'm boarding here. Let's mark that as my start position. That's one of the key things. So with word problems, one of the key things to have to start is you want to draw and have the start. That is one thing. So I'm starting over here. Next up, what we're going to see is what value do we care about. So we're boarding here, and as we just keep on labeling what we have a wheel of radius 3. Radius is probably important. It's moving counterclockwise. It's probably important. Speed, probably important. What we care about right here, we want to graph my height above the ground. So I want to see how high above the ground I am at every single moment. That is the value. That's a variable I care about. That's a value I care about. So going back to this, we board the first wheel at 3 o'clock. The wheel of radius 3, so it's labeled the radius. This 3 rotates counterclockwise at a speed of pi over 4 radians per minute. This is a ringing a little bell. Radians per minute, we see immediately that is omega. Pi over 4 radians per minute. So I kind of laid out everything I have. If we want to find the height above the ground, the next thing that I want to identify is for these problems, we want to see, like, are we oscillating here? Is this something that kind of repeats? And like, because before, like, it is kind of obvious for now, because like this unit we're using, those only functions we're working with. But as we do more and more, as we study for more and more exams, we want to kind of see how does this function differentiate from exponential functions, from polynomial functions, from rational functions. And the key thing here is, like, is something oscillating? Is some process repeating over and over again? And the first wheel does repeat. It moves in a circle, and a circle is kind of a key feature. We see, like, a circle is probably relates to trig. But the circle, we see, it's moving. I start over here, I go up, then I go down, and I go back to here. We are oscillating. So once you see we're oscillating, what you want to see are 3 key values. I want to see where's my max, where's my middle, and where's my min. So let's label this on my graph. And I see I care about my height. So my whole height right here off the ground. So my max, my mid, and my min. I want to see what is the most basic to start with. This first wheel, it didn't say it. I probably should include it, but we could assume it is touching the ground at the bottom. So therefore, the height above the ground is 0. My minimum is 0. Next up, I want to see either find my middle or my max. And to look at that, I want to just look at my first wheel for a bit. It has a radius of 3. Radius of 3 means every endpoint of the circle, every point of the circle, the distance from that to the middle is 3. Therefore, from going from the bottom to the middle must be 3. And then going from middle to the top must be another 3, so it's up to 6. So we have our start, our max, our middle, and our minimum. That's what we could draw with this. And what these things tell us, I'm going to draw some different color. The start tells us the function. Is it sine or cosine? And the max, mid, and min tells us a lot more information. It tells us kind of the vertical behavior. And what relates to the vertical behavior? Why, we have the amplitude, and we have some shifts. So with this information, let's actually start parsing through it. So first off, let's look at the max, mid, and min. What would my amplitude be for this? Keep in mind, amplitude, a little throwback to 4.4. What do we have for amplitude? Amplitude here is the distance from the midline to the maximum or minimum. So from the middle of 3, the distance to the max of 6 or the minimum of 0 is my amplitude. So my amplitude must be 3. Next up, I want to see my vertical behavior. Am I shifting at all? And there's some ways to see this, like vertical shift. One nice way of seeing it is your middle. Your middle shows you your vertical shift. I'll also show us another way that I did show in class. But we just see the middle and be like, how is this middle? Because the middle originally, think about where a middle is originally. Because we could see like all the max and min, that changes, but also changes from the amplitude. The middle only changes from vertical shifts. So middle originally for basic graphs of sine theta or cosine theta is 0. But now it's 3. So my vertical shift is plus 3. Next up, my function. My function is where am I starting? And I'm starting in the middle. Which of my two functions, sine or cosine, starts in the middle? So middle start means sine. So we have a lot of information already. Let's actually pause for a bit and let's write down my basic trig function. This I'm gonna write, but also like we'll also write down what we have normally for what do we need for graph as well? Because this one says graph. We want a function of time, but we also want a graph. So for a graph, if you think back to the previous lesson, to graph it, we need the amplitude, we need a period, and we need shifts. It's also shown here in our equation. I have my amplitude already. I have a vertical shift. We have to see if there's a horizontal shift, but we need my period. I need my period. So let's look back here and think about what do I have here that relates to time, because it's a function of time. And I see my time is right here. My speed, pi over 4 radians per minute. Time is right here with minutes, so that must relate to period. So if I have pi, let's actually go down here. I travel around at a speed of pi over 4 radians per minute. So since I travel this speed, let's actually look at this equation. Theta over time. I see time right here. Time is my period. How long is one full rotation? How long does it take for one full cycle? So let's think about, like, if I need to find t, I can't be given t. I'm given omega. I know this is pi over 4. This equals something over t. So since I want to find the time for one full rotation, what would theta be to show one full rotation? Yeah, so theta will be 2 pi, because one full rotation is 2 pi radians. Now at this point, we can solve for t, and you can solve any way you can, but I'm going to do the most basic way. The most basic way is I'm going to multiply both sides by t. Solve t like a variable. So pi over 4 t equals 2 pi, because these t's cancel out. Now divide by pi over 4 to get t equals 8. My period equals 8. My amplitude equals 3. And my shift, let's look at what we have. I'm saying we have a vertical shift of 3. Horizontal shift is about my start. Actually, they're both about my start. So horizontal shift is about my time, vertical shift is about my position. So we say I'm starting exactly at 3. At the 3 o'clock position. So I'm starting here at a height of 3. If this is my start, my vertical shift is plus 3. My horizontal shift is not anything at all. Because when we graph this, because graphing it is kind of like a balance between how much information can I write down and how much do I just want to graph and just like see the information I could get from my graph. So I'm going to graph this height. So once again, I'm going to draw this little circle, first wheel. I'm starting here at 3. I'm going up to 6. I could go down to 0. So as I go around it, I start at 3. I start at 0, 3. At time 0, I start at position 3. And this immediately tells us that there is no horizontal shift. So I have 3, up 3, up 3 units. And we can continue to graph. So sine goes up. I'm going up to 6. But I don't know my x. To find our x, we need to look back at our period and find my x step. X step is period over 4. So 8 divided by 4 gives me 2. So this gives me 2, 6. Then I go back down to 4, 3. Back down to 6, 0. And then up to 8, 3. And I see in one full period, from 0 to 8, my period of 8, I go up to 6, then I go down to 0, then I back up to 3. And my graph is done. This question did ask us just for a graph, but I also want us to make an equation, like here. So all my information is over here, rewriting it into my equation. A trig b theta minus h plus k. So the information that I have, amplitude is a, that's 3. My trig function is sine. My b relates to my period, so let's actually go back to find if period equals 2 pi over b, 8 equals 2 pi over b. So b, we multiply both by b. 8b equals 2 pi. Divide by 8 to get b equals pi over 4. pi over 4 times time, because I don't have theta in this case, I have time, minus h, my horizontal shift. I do not have a horizontal shift. So I could actually, you could write minus 0, but anything minus 0 just isn't anything. So that actually would go away. It's at pi over 4t plus my vertical shift of 3. This is my function. This is my graph. So take a minute, pause, look through this. I'm going to scroll through all this work and just narrate through it, and I'll let you guys talk through what my process is. So as I look through this question, I see a Ferris wheel. It's spinning. That tells me, and I want to find position. So the fact that I have something that oscillates, that goes back and forth, from up to down to up to down, I know immediately this is trig. This is sinusoidal function, trig function. Next up, what I need to do is I must draw a picture, find my start position, and find the range of my movement. So my max, my middle, and my min. This helps me see kind of where I start. It tells me what function am I. Sine starts at the middle. Cosine starts at the ends. It starts at maximum. So I know it's sine. It's going to start from the middle. Next up, I see this, the max, middle, and min, tells me my amplitude and my vertical shift. Because vertical shift relates directly to the middle. If my middle is 3, I must go up 3. If my distance from my middle to my end, that is my amplitude, so it's 3 as well. That gives me a lot of information. The next bit is my period. I need to find out how long is one full rotation. So look, I see pi over 4 radians. This is a little throwback to 4.3, like I said before, where I want to find the angular velocity, and kind of angular velocity tells me how fast I travel in an angle. So the angle I must travel is 1 full rotation, or 2 pi. So set up, so pi over 4 equals 2 pi over t to get my period of 8. And then I use all this information. I have my period now, I have my amplitude, and my shifts. My shift is only up 3 units because I'm starting at 3. So I start at 0, 3. Time of 0, position 3. No horizontal shift. I use that to graph, and I also use this to find my equation. There's a lot going on, but ultimately what we can see is if we have this, what I have circled right here, if you have this, that is all you need to go to the graph and also to go to the equation. The period, amplitude, shifts, I guess also like which one is it, sine or cosine? Like where you're starting. You need these 4 bits of information to graph or to find your equation. And these 4 bits of information could be found from either the graph or the equation, or also like a third thing, or like the word problem. So what I recommend is always trying to find these 4 values. What is the period? What's the amplitude? What shifts do I have? And what function am I using? That is what you should search for in these word problems. Okay. On Canvas, I'm going to upload. Also, I'll try again in the description of this. I'm not sure if it'll let me. I'll upload a document that kind of outlines this procedure in a more clear fashion. I might try to update it with like another example problem, but honestly, with this stuff, I want us to just practice it a lot and get used to finding these values. Because you could watch as many practice problems as possible. You could like have a little step-by-step guide. But I think by practicing it and actually applying it, because that it's good to have head knowledge of it, but then applying it in person, getting used to it, finding it quickly, finding tricks for yourself and understanding those tricks makes it better for you to be more flexible with using it, but also speeds it up the process. So I, like I said in my Canvas announcement, if you have any questions, if you have any topics that you want me to cover, any specific questions, please let me know by either let me know in class, send me an email, and if there's a demand, I'll probably make something up for it. Yeah, but good luck studying and take care.